All right, everyone, welcome to our final project presentation showcase. We're super excited to have you all here with us today. These lovely presenters have been handpicked through us to present their projects. They're awesome. We are going to be able to see some software engineering presentations today, as well as a data science presentation. And we're super excited to see what everyone has accomplished through their time at Flatiron School. So just a few things. You will have time to ask questions during and after the presentation. So go ahead. You can either use the Q&A function in Zoom, and we'll make sure that your questions get answered, or you can go ahead and drop your questions in the chat as well. I'll be monitoring both areas. So go ahead and just drop your questions there for our lovely presenters to answer. All right, with that, let's get started. First off, we are going to have Sofia Katzman sharing her final software engineering presentation, Milestones. Are you ready, Sofia?
Yes. Hello, everyone. My name is Sofia Katzman. I am from New York, New York. This is my project, Milestones. Milestones is basically a place where you can share all of your achievements or accomplishments or any of your milestones to share with family or friends or even recruiters if you'd like. To get started, you just have to log in. Sorry, forgot my password there. So once you log in, you're able to see all of your milestones. From here, you can filter your milestones based on the kind of milestone, so education, self-growth, achievements, etc. You can sort it by date. You can also have friends, so you can view your friends' milestones, and you can sort those as well. You can create new milestones, so testing. Hello. How are you? And 29, 21, 20, 23. I'm just gonna light change. So if we sort it, here we are, testing. You can edit this by just clicking edit. 1, 2, 3. You can also delete it if it's not something that you want to stay in your profile. I used a Python backend with Flask, and then my front end is React, which is a JavaScript framework. And then I have WebSocket as well, which creates a server that is always listening for events. And the idea behind that was that you could have a live feed. So anyone who creates new milestones while you're logged in will show up as a new update. And then you can also check out other people's milestones and then find their profiles and decide if you want to be friends with them. So I'm not friends with Brandy Walker. I'm going to become friends. And now if I go back to friends, where is he? Brandy Walker's right there. We're friends now. And yeah, to show you how the WebSocket works, I will just create a new account real quick. Testing. So obviously, new account doesn't have any milestones. Let's create one just for fun, very quick. Achievement. So now we have a milestone here, and this is a different server, a different browser, so that our cookies don't get mixed up. And now if I go on my feed here, well, it's not working today, but typically you would see that new update right there. So Milestones was meant to basically bridge the gap between introducing yourself to new people and having to explain your whole backstory to them so that they understand who you are. It came from going to a party and being tired of introducing myself to everyone and feeling like I kept repeating the same story. So I was like, why can't there be a place that you could just have your life as a timeline where you can share and people can get to know you very quickly? So that's Milestones. Thank you for tuning in.
Thanks so much for sharing, Sofia. Do we have any questions? Got some compliments. Great project.
Thank you,
Talking to
Sad.
Donna.
Thank you, guys. I'm glad you appreciated it. Yeah, it would be really cool to have it integrated with LinkedIn. The difference between HTTP request and WebSocket is that typically with an HTTP request, you either have to use state or refresh the page to see it. And since these are not users that have access to other users' logins, the WebSocket remains open as long as the user's logged in and then closes when the user logs out. So it's just listening for worldwide being application-wide updates. Thank you so much, everyone, for all these amazing compliments. I'm really flattered that you enjoyed this project.
Love it. Love to see all the love in the chat. Thanks so much. If there's no more questions, if you have any more throughout the projects, go ahead and just drop in the chat and just say for Sophia, and we'll make sure to go ahead and circle back and get those answered. All right, next up we have got Lillian Lakes with her project Card Fraud Detection. Are you ready to go, Lillian?
I am, thank you. I'm gonna start my video. Share screen.
That was amazing.
Thank you.
You're so good at presenting.
Can everyone see my screen?
Yes, we can.
Okay. Hello, everyone. Today, I'll be sharing my project on card fraud detection of an e-commerce transaction data set. Let's see, one second. A little about my background. My recent work experience has been in software engineering. Prior to that, I worked in data analysis and finance. I have a bachelor's in economics and management information systems and 2 master's degrees with the latest in research. I recently completed Flatiron's data science bootcamp, and I'm on the market for data science positions. As part of this presentation, I'll be starting with the business problem, going over data and models, and ending with recommendations and future steps. Now I'll go over the business problem. Financial institutions care about accuracy and want to minimize false positives by not incorrectly flagging good users. They also want to minimize false negatives where they fail to flag fraudulent e-commerce transactions. Here are a few facts and figures on card fraud detection. Card fraud is on the rise, with global losses from debit and credit card fraud almost doubling between 2014 and 2021. Global losses from card fraud are expected to be $397 billion over the next 10 years. In 2021, the FTC fielded 390,000 reports of card fraud, and credit card fraud is the second most common type of identity theft in the US. Lastly, 87% of US consumers use public Wi-Fi for online shopping, whether at a cafe, airport, or hotel. In this project, I present recommendations to help financial institutions accurately detect card fraud, minimize cost, customer churn, and losses related to identity theft. The bottom line, purchases made within the first 137 seconds of sign-up, and those from a device used multiple times are more likely to be fraudulent. E-commerce transactions in January following the holiday shopping period also have a high risk of fraud. Now I'll go over the data. The raw data comes from 2 data sets from Kaggle, a fraud data set and an IP table. The fraud data set includes 151,000 entries and 11 variables, including sign-up time, purchase value, device ID, user ID, browser, IP address, and so on. The IP table includes almost 139,000 entries and 3 variables, including IP address, upper and lower bounds, and country. I used this data set to map the IP addresses in the fraud data set to an origin country. Prior to visualizing and modeling the data, I performed a lot of feature engineering. For example, I mapped IP address to countries using the IP table and created several variables related to countries. I also engineered sign-up and purchase time to create variables for purchase month, weekday, period of day, and a quick purchase variable indicating whether or not a purchase was made within 137 seconds of sign-up. I used device ID to create device frequency, the number of times device was used in the data set. Now I'll go over the exploratory data analysis. First, I looked at the likelihood of fraud on the y-axis by purchase month on the x-axis. I found that January, following the holiday shopping rush, has the highest likelihood of fraud. Next, I looked at the likelihood of fraud on the y-axis by whether or not a purchase was made within 137 seconds of sign-up on the x-axis. In this data set, purchases made less than 137 seconds after sign-up were all fraudulent. I also looked at the likelihood of fraud on the y-axis by the number of purchases made from the same device on the x-axis. I found that fraud is more likely to occur when purchases are made from the same device. Next, I analyzed countries, beginning with the top 12 countries with the most transactions. IP addresses from the United States are more represented, followed by IP addresses that are not traceable. I delved deeper into the analysis of countries by looking at the likelihood of fraud on the y-axis by country on the x-axis. Of the top 12 countries with the most transactions, Canada had the most fraudulent transactions, and the United States had high fraud levels. Hidden IP addresses are unknown and also in the top 10. I dug even further into the country analysis by using a map to explore the number of transactions, amount of fraud, and the breakdown of quick purchases by country. The United States has the most transactions overall and fraudulent, with a high proportion of purchases made less than 137 seconds after sign up, as evidenced by the pie charts. Now I'll go over the models. I explored several models to analyze the e-commerce transactions and identify high predictors of fraud. The performance and interpretability of these models is summarized in the table. The logistic regression models, both the simple model and the one with lasso regularization, performed well and are easy to interpret, with accuracy scores of 92% and 91.6% respectively. I got straightforward quantifiable insights from the odds ratios. The logistic regression model suggests that purchases made 137 seconds after sign up are 110 times more likely to be fraudulent. It also shows that a device used one additional time is 8 times more likely to be fraudulent. The logistic regression model with lasso regularization suggests that purchases made within the first 137 seconds of sign-up are 39 times more likely to be fraudulent. Here, a device used one additional time is 29 more times to make a fraudulent purchase. Now I'll go over recommendations. I recommend that financial institutions adopt a fraud probability scoring model to evaluate e-commerce transactions. This model should heavily weigh quick purchases and device frequency, along with other predictors that are most relevant to each institution, for instance, purchase value. The fraud risk of each transaction could be gauged from the scoring model such that transactions with low probability scores proceed with no interruptions. Transactions with medium probability scores would need to pass two-factor authentication before proceeding. And transactions with high probability scores would need to be approved via call to the financial institution's fraud prevention line. I also recommend that financial institutions staff their customer service and fraud prevention departments higher in the months of January, when fraud risk is higher following the holiday shopping period. Now I'll go over future steps. Future areas of analysis that could build upon the findings from this project include a time series analysis to spot fraud trends over time. I would also like to find publicly available real data sets with mostly transparent data and detect other forms of identity theft, such as government benefits and documents, the most common form. With that, thanks for listening to my presentation. I hope you found it insightful. If you have any questions, please drop them in the Q&A section of the chat, or feel free to reach out to me on LinkedIn for more information. There are links to the presentation on the GitHub where you can view sources used and more details on the models in the appendix section. Thank you.
Wow, thank you so much for sharing with us, Lillian. It's so scary to think about all of that information being stolen from us. Super impressive. Thanks for sharing. Do we have any questions?
Thank you.
Seeing a lot of love. Oh, yes. And great call out. The visuals were really amazing.
Thank you.
Okay, I'm not seeing any questions. seeing someone say some glad you're not in the same field. I would hire you over me.
Thanks, everyone. Appreciate it.
Love it. If you have any questions as we go on to our next, oh, thank you for saying that. We have a question. How did you calculate 137 seconds?
So I had variables for the purchase time and the sign up time. So I used feature engineering to calculate time since sign up. And then I used the date time. I used, daytime feature engineering to calculate how many seconds since sign up. And after doing, exploratory data analysis, I saw that at 137 seconds, like everything was fraudulent before that. So that was what I used as a cutoff. But basically, I use that to gauge, my quick purchase variable. But yeah, feature engineering based on purchase time and sign up time.
Thanks for explaining. Okay. As we did last time, if you have any questions that come up for Lillian, go ahead and drop them in the chat. Oh, got one more. Does that mean that the time of day a factor probability of fraud?
I did see some interesting patterns with the time of day, but mostly it's because we're looking all over the world. So obviously, the time of day varies, but say just quick purchases was one.
Awesome. Okay. Seth's asking for a front engineer to collaborate on a project. So if anyone wants to do that, go ahead and drop your info in the chat for Seth. We have one more in the Q&A. How did you pick which model to use?
So I looked for models that were easy to interpret. I ran probably 8 or 9 different models, and some like logistic regression are easy to find quantifiable insights. And I also looked at the accuracy score, and financial institutions care about accuracy score because you don't want false positives where you incorrectly say something is fraudulent when it's not, or false negatives where you fail. So accuracy score minimizes both the false positive and negatives. There's other ways to evaluate a model. You could look at precision, you could look at recall, but accuracy score was what I used just because that minimizes both the false positives and false negatives. Those are both equally important.
Awesome. Thank you so much. Okay, I'm not seeing any other questions in the chat or in the Q&A section. So I think you're out of the fire now, Lillian.
Okay.
Thank you again
But
for
please
sharing.
do reach out to me on LinkedIn or GitHub if you have any questions or anything. Thank you for your time.
Yeah, absolutely. All right, last up, but certainly not least, we have got Jensen Lawless with her software engineering final project, Site Scout. Are you ready?
Yes, I am.
All right.
All right. Hello, my name is Jensen, and I did the software engineering program in person in Denver, and I just graduated this past August, and this is my project Site Scout. So quickly, going into a little bit of the agenda, I'm going to talk about why or the problem that I wanted to solve, give a quick demo, bring up some challenges that I faced, and talk about where I see the project going next. So the why, or kind of the problem that I found. What is Site Scout? I envisioned it as a website to help new or small business owners manage and compare potential new addresses for their brick and mortar locations. So an example we can follow throughout this demo is, there's a new coffee shop that's opening and they're debating where their new location should go. And this problem actually came out of a real life problem that my partner had when they were consulting for a gym. And they wanted to, open a new location, but they wanted more information about the area that they were going to open in. So say we're the new coffee shop and you think, my customers typically drive from around 15 minutes around to get my coffee. I wanted to visualize on a map, like the picture that's shown here, what is that 15-minute driving distance, and get more information about that area. So quickly showing my website. So I used clerk authentication so users can log in with Google, LinkedIn. There's a whole bunch of other options, but these are the ones I went with right now. I'm just going to log in as myself for now to kind of show you. So when you go to the site, it's pretty simple, just kind of gives an overview of Site Scout and how to use the project. So let's get started. So for an address, I have just been using kind of the same 5 addresses over and over to look at it. So let's say we want to look at this address. This is where I might open my coffee shop, and I want to know everything that's within a 10-minute driving range. So we hit submit, and this shows us everything that, is around that area. So you can also change this, and let's say we want to see 30 minutes around this area. Might take a second because it's a bit of a longer ask. But as you can see, it's not directly as the crow flies. It follows roads and paths to show you exactly where that area is. So 30 minutes away, it gets a lot more precise because you can only go so far on the roads. So you go to your maps, and right now I just have every map that's submitted pops up on here so that you can compare. But you can delete. So let's say like I no longer am really looking at this location, so I can delete this map. But over here, you can compare, different addresses, you can compare different driving times, all sorts of things. And I wanted to provide an example too of what this looks like around water. So again, it's, everywhere that can be driven by this point. So like this right here and all over there. So pretty simple front end, to be honest. But a lot of what I focused on was on the back end. So I'll kind of go back to here. Definitely the hardest part of this project was just working with all the different data types. So as soon as a user inputs that address and driving time, it makes a call to a Google geocoding API, which returns a latitude and longitude coordinate, which then sends it to Open Route Services and returns basically something called a GeoJSON object, which is a long list of coordinates that form that isochrone polygon, which is that shape that you see around the center. Then kind of in the back end, I'm storing that user, the address, and the coordinates along with the time range in a database, and then rendering that map via Leaflet, which is a mapping service. So all of these different calls are taking place in like a couple of seconds when you hit submit. And this was definitely the toughest part, was just figuring out all of these data types. They didn't all quite match. Like some of the longitude and latitudes were reversed, so I had to figure out how to get those in the right order. And then storing stuff in a database with GeoJSON objects was really difficult as well. So next areas of focus, I would love to expand this project. I think the next couple things that would be helpful would be adding a points of interest API. So if you're a coffee shop, you want to see all the other coffee shops in the area, your competitors, and how well they're doing, what they're rated, how much they're charging for coffee, just get all of that information. And then I'd love to incorporate the US Census Bureau data. So Lillian will have to chat. I saw you used to work there. But just to include average income and population within that polygon area. I think that would be really cool and helpful for business owners as well, knowing just, how much people are making in the area and what the average population is, or the population is. And then with open route services, I think in big cities, it'd be great to include something like walking or biking distance as well, not just driving. So I know that's a more popular modes of transportation. Tech stack, I used Vite and React for my front end, Flask and Python for my back end. And for the database, I had to go with PostgreSQL with a PostGIS extension, just because it's a little bit tougher to store those GeoJSON objects in a database. Leaflet was the mapping that you saw on the page. Material UI was the front end, kind of like the design, and then Clerk was the authentication. This link will take you to my LinkedIn. So if you guys want to add me, I would love to connect with you. But yeah, that's kind of all I have for right now. Thank you so much.
Awesome. Thank you so much for sharing. I got one question right off the bat. Does traffic during hours of operation affect the distance that can be reached within a time range for driving?
Yeah, I think that it takes it into account. Open Route Services does. There's a couple of different options. Like some of them didn't take traffic into account. Some of them were just like an average time overall. I think I chose the option that was like just average time in general.
Gotcha. Awesome. Seeing, as usual, a lot of love in the chat. Okay, I got a question. Does leaflet mapping also allow that map interaction where you could zoom in and out?
Yes, Leaflet does all of that, which was really cool. Leaflet has a ton of different features too that I didn't even get to scratch the surface of, but you can add different points on it. You can change like colors, you can zoom in and out, you can have it render different points when you first render the page. Leaflet was a really cool service to work with.
Awesome. Thanks for sharing. Did you learn all of these with Flatiron? Which things did you learn on your own?
Yeah, I did learn all of this with Flatiron mostly. The React, Flask, and Python, which were all the basics of what I learned. All of that was there. And then Leaflet, I learned on my own, but it was really simple to learn with a few tutorials. The only one that I kind of learned a little bit more about was the Postgre database. We'd been using a lot of like SQLite for our databases, so I had to learn like a new database system, but everything else was through Flatiron.
Awesome. Okay, any other questions for Jensen or any of our panelists? A lot of love. Great work. So good. Clapping. Great job, Jensen. Oh, 2 more in the Q&A. Okay, I think that Google should integrate that into their map. I really face that problem when I'm searching for my apartment to rent, and the addresses on their site are not very much reliable, and Google Docs does not provide that feature. Totally.
Yeah, it would be like a combo of like Zillow and Google Maps and something, somewhere where you could kind of get all that information. That'd be cool.
Why React/Vite and not React alone?
The was just a very quick, I think it makes it like quite a bit quicker as an app. I'm not totally sure, to be honest. I just thought Vite was like really easy to use and learn and implement. And I had used it for a couple of other projects and really liked the outcome. And then I saw one more. What use cases do I see? Yeah, I think originally, I think it'd be really cool for small business owners. I feel like I'm very passionate about like local businesses and communities, so I think it'd be really great for them to have a tool like this. But I agree with whoever put that about rent. I think just great information for anyone to have like everything all in one place makes it a lot easier to compare locations.
Totally. Love everyone dropping their LinkedIn information. Go ahead and do that if you're an attendee too and you want anyone to connect with you. Love having everyone share their contact info, but I don't see any other questions. Thank you so much for presenting, Jensen. We really appreciate it. That wraps up our final project presentation showcase tonight. So we're really great that y'all were able to come and join us. I'm going to go ahead and stop the recording and then I will hang around for a little bit.